Now in this video we are going to take up one more problem on the projections of laminas. The problem reads as a regular pentagonal lamina of 25 mm side is resting on one of its corners on HP, while the side opposite to this corner touches VP. If the lamina makes an angle of 60 degree with HP and 30 degree with VP, draw the projections of the lamina. So how to analyze this problem in 3 dimension and how to solve this manually. So to do that, so he says that a pentagonal lamina of 25 mm side is resting on one of its corners on HP. Whether in a pentagon, if whether it is a corner is resting on HP or the side is resting on HP, always you make sure that one of the edges are perpendicular to VP, because the side opposite is always a corner. So while the side opposite to this corner touches VP. If the lamina makes an angle of 60 degree with HP and 30 degree with VP, draw the projections. Since he has given the surface inclination with respect to both HP and VP, so obviously you have to write the profile view where you will going to get the surface is perpendicular to the profile plane. That we are going to see at a later stage. Since it is resting on HP, on one of the corners on HP, and also the surface inclination is given with respect to the HP. So first we are going to start the problem using from the top view. Now we will first analyze it in 3 dimension. So as I already told you, since it is a pentagon, since it is a side opposite is a corner, so always you make sure that whether it is resting on side or a corner, it should rest always on the one of the side is perpendicular to VP. So here, when you look from this front view, you can see that since the surface is perpendicular to VP, you are getting a line in the top view. Oh sorry, you are getting a line in the front view. So now, here in this you can see all the sides are resting on HP. So obviously the lines are parallel to HP. Since the lines are parallel to HP, so you are getting the true shape in HP. Where is HP? HP is here now, you can see. So therefore, you will be able to see the pentagon of each side is 25 mm. All the sides are in true line. So when you look from the top view, the pentagonal surface is seen in the top view, that is on HP. So when you look from the front view, you are getting a line because it is perpendicular to VP. The surface is parallel to HP and perpendicular to VP. So that is the reason why you are getting a line in the front view. Now, when you look from the top view, A, B, C, D, E is visible. So when you look from the front view, A, B, C is visible. So A dash, B dash and C dash is visible. D and E is away from the observer. So therefore, D dash and D dash is in bracket. Now let us see how it can be solved by using manually. First we are going to draw the XY line and you mark VP and HP. So then you measure in the sketchbook, you measure the distance of 25 mm and draw a vertical line with a dark line. You mark this as A and E. By using the protractor with reference to this vertical line, you measure an angle of 108 degrees, which may be included angle, or 72 from the exterior angle. With A center keeping with respect to AE, the protractor, you keep the center of the protractor on A, and by with respect to AE, you measure an angle of 108 degree, which is the included angle, and mark a point. From then, from A to that point, you join and extend. Similarly, with E center taking with respect to EA, you measure an angle of 108 degree, which is the included angle, then draw an inclined line. Then by using the compass, by measuring the distance of 25, with A center, cut an arc on this inclined line. Similarly, with A center, cut an arc on this inclined line. So now you mark this point as B and D. With B as center, take the same radius of 25, draw an arc. With D as center, cut on the previously drawn arc. And you mark that point as C. Then join A to B, B to C, C to D, D to E and E to A with a dark line. Now from A and E you draw a vertical projector to the XY line. Similarly from B and D you draw a vertical projector to the XY line, and also from C to the XY line. Then as you look from the front view, you mark this as ABC near to the observer. So A dash, B dash, C dash is visible, and D and E is away from the observer. Therefore, D dash and D dash will be in bracket. As we are joined between A to B and then B to C, therefore you join between A dash and B dash and B dash C dash with a dot line. So since all the sides are parallel to HP, so you are getting the true length in HP. Since this surface is perpendicular to VP, you are getting a line in the front view. As we see that AB and BC both are inclined to VP, therefore A dash, B dash and B dash, C dash will not be in true plane. It will be in apparent plane. Now, then he says it is resting on one of the corners. So this is a side and this is a corner. How do I know that this is a side? When you look from the top view, AE is the line which is a side which is perpendicular to VP. Therefore, you are getting a point here. Since it is perpendicular to VP and parallel to HP, so you are getting a point in the front view. A dash, C dash. This is the side. And here C dash is only one point. So that means it is a corner. Then he says it is resting on one of its corners such that the surface is inclined at 60 degrees to HP. So with C is on HP, you rotate this pentagon by an angle of 60 degree with respect to HP. So once you rotate this by an angle of 60 degree with respect to the head plane, what happens to the position of that line lamina with respect to VP? Still it is perpendicular to VP. Therefore, you are getting a line. So as you rotate this hexagon with respect to HP, then what happens to the image in the vertical plane? The image in the vertical plane is also being rotated. So that means initially A dash, A dash is here. So now A dash, A dash has gone above HP such that the entire surface is inclined at 60 degrees to HP, keeping C dash, that is C, on corner point on HP. So that is what we can see here. The corner point is on HP. So when you look from the top view, A and E, which was above HP, is being projected onto the horizontal plane. Similarly, B and D is also projected on the horizontal plane. So you mark these A, B, C, D, E and A. You join all these things. So now this is how you will be able to get the image when you look from the top view, and this is how you are going to get the image when you look from the front view. Now how to analyze this in two dimension? Let us see. Now you extend this XY line and consider any point on the XY line and you mark that point as C dash. Then by using the protractor with C dash as center with respect to the XY line, you measure an angle of 60 degrees in the clockwise. Then you draw an inclined line of 60 degrees. Then by using the compass with C dash as center, taking the radius of C dash A dash with C dash as center, cut an arc on this 60 degree line. And as you are measuring the distance from C dash to A dash, you mark this point as A dash and A dash in bracket. Similarly, then you measure the distance from C dash to B dash with C dash as center, cut an arc on this 60 degree line. And you mark this point as B dash and D dash in bracket. Then join A dash to C dash with a dot line. So when you look, then I need to write the top view. Draw a vertical projector from A dash and D dash to the XY line and extend in the top view. Draw a horizontal projector from both A and E. So these two lines will going to intersect at this point and also at this point. And you mark that point as A and you mark this point as E. Then draw a vertical projector from B dash and D dash to the top view. From B you draw a horizontal projector so that it is going to cut here. Similarly from D also you draw a horizontal projector so that it is going to cut on B dash D dash projector. And you mark these 2 points as B and D. Then draw a vertical projector from C dash and draw a horizontal projector from C. Both these two endpoints will going to intersect at this point. You mark that point as C. Then join A to B, B to C, C to D, D to E and E to A with a dot line. Then the side opposite to the corner is resting on VP. So what does it mean? Now what is the side, which is the side which is opposite to the corner, which is AE? What is the position of AE with respect to VP and HP? This side is parallel to HP. How do I know that? A dash, both A dash and E dash is above HP by same distance. Now the line is parallel to HP. Therefore, you are getting the true length here. What is the true length of the line? The true length of the line AE is 25 because A dash D dash is parallel to HP. But what happens to the position of the surface with respect to HP? So with respect to VP. So you are getting a line. And now what he says, the corner, the side opposite the corner touches VP, AE. So what should happen? AE should touch vertical plane. So that is what we have shown here. AE is A dash, E dash is touching VP. C is touching HP. So this is the grey color what you have in the three-dimensional surface, wherein the pentagon is the side is resting on VP and the corner is resting on HP. Now when you look from the top view, that image will going to fall on this A, B, C, D, E and A. Similarly, when you look from the front view, A dash, E dash is on vertical plane. B is in front of VP, so you project this B dash and D dash to the vertical plane as you look from the front view. And then C is already here, so the C is resting on HP. Now, since the surface is inclined to both HP and VP, so obviously that surface is to be perpendicular to VP. That's what you can see. But we can see surface inclination with respect to HP here because the surface is perpendicular to VP. But now the surface is neither perpendicular nor parallel. Instead, it is, since it is the surface which is inclined to both HP, that is HP and also on VP. Okay, therefore this surface will going to become perpendicular to the profile plane. So therefore you are getting a line in the side view. So as you look, since this is the right profile plane, as you are looking from the left side, A, B and C are visible. So that means A dash, A double dash, B double dash and C double dash are visible. To this B dash, D dash is away from the observer. So D dash becomes invisible. That is D double dash becomes invisible. Therefore, you are keeping this D double dash is in bracket. Similarly, as you look from the left side view, A dash is near to the observer. So it is visible, that is A double dash, and E double dash is away from the observer. Therefore, E double dash is in bracket. So, and so what happens, as the surface is becoming inclined at 60 degrees to HP here, because that 60 degrees here, obviously that surface will be inclined to VP at 30, because since it is a right angle triangle, wherein you have 90 here, if this is 60 is given, so 90 plus 60 is 150, so obviously this should be 30 only. But of course, here he has given the surface inclination with respect to HP and also on VP. Please remember this, whenever he has given the surface inclination with respect to the both HP and VP, obviously you must write the side view, because in the side view only you will be able to see both the inclination with respect to HP and VP, because that surface is perpendicular to the profile plane. Therefore, you are getting a line in the side view. One should do that. Now, how I will be able to write that on 2 dimensions? So, as he says that the corner is resting on HP, the side opposite the corner touches VP. That means AE should touch is on VP. So, at present is what is happening. A dash, E dash is parallel to HP and it is perpendicular to VP. Since I want to keep this side on VP, so obviously now this side is perpendicular to VP. I have to make it parallel. So how I can make it parallel? By rotating or by rotating in clockwise direction in the second position top view. That's what we have done here. By rotating the second position top view, that is this one, and keep it on XY line. So that is what I need to do. So that means I want to rewrite the same sketch by rotating at an angle of 90 degree in clockwise only. You cannot rotate it anti-clockwise because C will come here, AE will come here. So that is the reason why you cannot rotate in clockwise, anti-clockwise. So I need to rotate in clockwise. So to do that, you measure the distance from A to E by using the compass and consider any distance on the XY line. You transfer it onto these 2 points. And you mark this point as A and you mark this point as E. Similarly, you measure the distance from A to this point, and from A you cut it on this, so you are going to get this point here. Then draw a vertical projector to the top. Similarly, you measure the distance from this point to this, and from this you cut it, you get C. Similarly, you measure the distance from this point to here, to transfer it from this point to here. Okay? Then draw a horizontal projector through this point which you have marked. Then by using the compass, you measure the distance from this point to here, which is the same as from this point to D. So, which is this point here in this? This is the point what we are talking about. So from here you have drawn a horizontal line. So you measure the distance from this point to B and also from this point to D. Both will have the same distance. With this as center, cut an arc on this side and also on this side. You mark these 2 points as B and D. Then join E to B, B to C, C to D, D to E and E to A with a dotted line. Now I need to write the front view. So to do that, from C you draw a vertical projector to the XY line, as C dash is on XY line, so you mark that point as C dash. And draw a vertical projector from both B and D to the front view, and draw a horizontal projector from B dash and D dash. You are going to get this point B dash, you mark that point. Similarly, you are going to get this mark here, so you mark that as D dash. And then draw a horizontal projector from A dash and E dash, and draw a vertical projector from both A and E. Both these two lines will going to intersect at these 2 points. You mark this as A dash and you mark this point as E dash. Then join A dash to B dash, B dash to C dash, C dash to D dash, D dash to E dash to A dash with a dot line. And from here I need to write the side view because the surface is inclined to both HP and VP. So you take any convenient distance and draw an x1, y1 line and you mark those as x1, y1. Then you draw, by measuring an angle of 45 degree with respect to the xy line, you draw an inclined line. So that this is will go to be the 45 degree line. Then you draw a horizontal projector from AE to the origin because AE is on VP. So obviously here on vertical plane, x1 to here is the vertical plane. So AE, that means A double dash, E double dash will be on xy line. So x1, y1 line. How do I know that? If you look from the side view, A dash is near to the observer, so A double dash is visible. E dash is away from the observer, therefore E double dash is in bracket. And similarly, draw a horizontal projector from both B dash and D dash, and then from xy line, from the origin, by using the protractor, you measure an angle of 45 degree and draw an inclined line. And from B and D, you draw a horizontal projector to the 45 degree line, and from here you draw a vertical projector to the side view and draw a horizontal projector from B dash and D dash. Both these 2 points will going to intersect at this point. You mark this as you look from the left side view, so B double dash is visible and D double dash is away from the observer, therefore D double dash is kept in bracket. Similarly, you draw a horizontal projector from C dash and draw a horizontal projector from C to the 45 degree line, and from this point you draw a vertical projector to the XY line because C dash is on HP. So now you got this point. So you mark this as C double dash. Now I want to write the visibility and invisibility. As you look from the left side view, A dash, B dash and C dash is near to the observer. So A double dash, B double dash and C double dash is visible. As D and E is away from the observer, therefore D double dash and E double dash is in bracket. So this is how you will be able to analyze this problem in 3D and also how to solve the problem manually by using the sketchbook. So you dark line between B dash and A double dash and C double dash, and you mark the dimensions of 60 and 30. Now how do I know that my problem is right? You can see that the corner is resting on HP and the side opposite the corner touches VP. This corner is resting on HP and the side opposite the corner is touching VP, that is here. And then it is resting on one of its corners on HP, which is inclined at 60 degrees to HP. And this is a side of a pentagon of 25 mm side. So this is all, and hence is I have incorporated all the data given in the problem into getting the solution, and hence my problem is right. So this is how you will be able to analyze in 3 dimension and also can be able to solve the problem by using the sketchbook. Thank you.